Congratulations on completing the course. Now that you have a solid grasp on designing, managing, and modernizing enterprise data systems, you will discover numerous opportunities to further your learning and apply your newly acquired skills. Before moving ahead, let's recap the key concepts you learned throughout this course. Enterprise Data Architecture, or EDA, provides a structured approach to organizing, integrating, and governing an organization's data assets. EDA consists of three types of data models: conceptual, logical, and physical. These data models define, organize, and manage data and serve as a database design blueprint. An organization's data processes and technologies are defined using a data architecture framework. It enables organizations to align data strategy with business goals. With organizations shifting to cloud-based and hybrid cloud environments, Data Fabric and Data Mesh are important frameworks for managing, integrating, and accessing data across complex and diverse systems and environments. The principles that help to implement EDA include data integration and interoperability, scalability and performance, data governance and security, real-time processing, and modularity. Organizations use ETL to extract data from various sources, transform it into a structured format, and load it to a centralized repository, making it usable for BI, analytics, and operations. Organizations use data ops to manage the challenges of data volume, variety, and velocity. Data ops automates repetitive tasks to reduce human error and accelerate data delivery. The data lifecycle has 6 stages: creation and ingestion, storage and organization, processing and transformation, analysis and utilization, governance and security, and archival and destruction. Integrating new technologies and paradigms into existing systems and workflows requires strategic planning, organizational alignment, and robust execution. Enterprises must assess technical, organizational, and operational readiness before starting an integration initiative. Application architectures significantly influence data operations, shaping how data is ingested, stored, processed, and secured. You also learned that migrating applications, data, or entire workloads to the cloud or re-engineering existing infrastructures requires an approach that minimizes interruptions, optimizes resource use, and accelerates the modernization process. Modernization entails moving from legacy systems to innovative architectures through rehosting, replatforming, refactoring, and replacing outdated solutions. You have now reviewed some of the fundamental concepts covered in this course. Remember to go through the glossary at the end of the course to review the key terms discussed and their definitions. You can also share the apps you created in the labs and the final project on GitHub. These projects can serve as examples to showcase your skills to potential employers. This course included hands-on labs and a final project. By completing the labs, you gained practical exposure to the following topics: consolidation of data infrastructure, create an EDA blueprint, choose the right technologies for a given requirement, choose storage types based on data lifecycle, redesign a schema designed for OLTP and modify it to suit OLAP, document, migrate an RDBMS schema to a NoSQL database, draft a retention policy for an oil exploration company. We recommend continuing to use the concepts you've learned. We hope these principles will hone your skills and help you advance in your career. Congratulations on completing this course. We appreciate your participation in this learning journey and wish you the very best.